The world of 312 million years ago was not a place built for the weak. It was the Carboniferous period, a time of high-octane biology. The atmosphere was thick with oxygen, fueling the growth of club mosses as tall as skyscrapers and dragonflies with wingspans the size of hawks. But for the masters of the land, the early tetrapods, there was a tether they could not break. Like the frogs and salamanders we know today, they were prisoners of the water's edge. Their skin was thin, and their eggs were jelly-like. To leave the swamp was to desiccate and die. But in the shadows of these giant scale tree forests, a quiet biological coup was underway. Imagine a creature no larger than the common lizard scuttling through the damp leaf litter. This is Hylonomus. At first glance, it doesn't look like a pioneer. It has small, needle-like teeth for crunching on early insects and a slender body. But Hylonomus possessed a secret, a biological spacesuit that would change the course of life on Earth forever. This secret was the amniotic egg. Until this moment, vertebrate life was trapped in a cycle of return. No matter how far a tetrapod wandered, it had to return to the pond to lay its eggs. The amniotic egg changed the game by bringing the pond inside the shell. Within this porous yet protective casing, a series of membranes, the amnion, chorion, and allantois, worked in perfect harmony. The amnion cushioned the embryo in a private pool of fluid. The allantois handled waste and respiration, and the yolk provided a concentrated fuel source. This was the amniotic revolution. It was the ultimate liberation. Because of this egg, Hylonomus and its kin didn't need the swamp. They could march into the heart of the supercontinent Pangaea. They could survive in environments where an amphibian would wither in hours. But the egg wasn't the only upgrade. These early reptiles were also developing a tougher, waterproof skin covered in scales and a more efficient way of breathing. Unlike their ancestors who partly breathed through their skin, these rebels developed a rib-powered suction chest, allowing them to take deeper gulps of air. As the Carboniferous shifted towards the Permian, the climate began to dry out. The great coal swamps began to fragment and disappear. For the giants of the swamp, it was an apocalypse, but for the tiny egg-laying innovators, it was an opportunity. They weren't just surviving the transition, they were inheriting the Earth. They were the first reptiles, the ancestors of every crocodile, every dinosaur, and every bird that has ever flown. They had broken the tether to the water, and the vast, dry interior of the world was finally theirs to claim. By the late Carboniferous and early Permian, the amniotic revolution had been won. The world was an open canvas, but nature was experimenting with the blueprint of the reptilian head. If you were to look at the skulls of these early pioneers, you would see the primary difference that would dictate the next 300 million years of history. Imagine the skull as a biological machine. To eat tougher plants or more elusive prey, you need stronger muscles. But muscles need space to bulge and anchor. The early amniotes, like the small Hylonomus, had anapsid skulls, solid bone behind the eyes with no openings. It was a sturdy design, but limited. Then came the Great Divergence. Two rival engineering paths emerged. First, there were the synapsids. These creatures developed a single opening, a window behind each eye socket. This allowed for more complex jaw muscles and eventually specialized teeth. These weren't just reptiles, they were the mammal-like reptiles. In the scorching deserts of the Permian, giants like the sail-backed Dimetrodon ruled their day. They were the dominant predators of their time, roaming the supercontinent of Pangaea. They were our distant ancestors, reptilian in appearance, but carrying the genetic torch that would one day lead to fur, milk, and humanity. But lurking in their shadow was a second group, the diapsids. The diapsids took a different approach, evolving two windows on each side of the skull. This made their skulls lighter and gave their jaw muscles even more room to expand. While the synapsids dominated the Permian, the diapsids were the underdogs, mostly small, agile, and waiting for their moment. They were the ancestors of every lizard, snake, crocodile, and dinosaur yet to come. As the Permian progressed, these two lineages lived in an uneasy balance. The synapsid mammal cousins were the heavyweights, developing massive bodies and complex social structures. But the Earth was changing. The continents were drifting together to form the massive, arid interior of Pangaea, and the climate was becoming a volatile pressure cooker. Then, 252 million years ago, the world broke. The Great Dying, the Permian-Triassic extinction, wiped out 90% of all species. The volcanic eruptions of the Siberian traps poisoned the air and turned the oceans acidic. The great synapsid empires crumbled. When the dust finally settled and the Triassic sun rose over a scarred world, the stage was empty. The synapsids had been brought to the brink of total erasure. But the diapsids, the two windowed survivors, were leaner, more water-efficient, and ready to sprint into the vacuum. The age of the mammal-like reptile was ending. The era of the ruling reptile was about to begin. The Triassic period began on a scorched, empty Earth. The synapsids, mammal-like reptiles that had dominated the previous age, were devastated, leaving behind a power vacuum. From the fringes of the disaster emerged a group of diapsids known as the archosaurs, or ruling lizards. These were not your modern, sluggish garden lizards. The archosaurs were a revolutionary lineage that split into two massive empires, the pseudosuchians, the crocodile line, and the avematalisalians, the bird and dinosaur line. For most of the Triassic, it wasn't the dinosaurs who ruled, it was the crocodile line archosaurs. Imagine a world where the ancestors of crocodiles didn't just swim in rivers, they sprinted on land. Creatures like Postosuchus were the apex predators of Pangaea. They stood on upright, pillar-like legs, carrying their weight directly beneath their bodies rather than sprawling to the side. This was a biomechanical breakthrough. It meant they could grow larger, move faster, and breathe more easily while running. While these Triassic crocodiles dominated the landscape, the early dinosaurs were small, bipedal sprinters living in their shadow. But the archosaurs as a whole possessed a physiological secret, a highly efficient respiratory system. Many archosaurs developed a one-way breathing system, similar to modern birds, which allowed them to extract more oxygen from the thin, carbon dioxide-heavy air of the Triassic than any remaining synapsid could. Then, approximately 201 million years ago, the Earth underwent another transformation. Huge volcanic rifts opened as Pangaea began to break apart. This Triassic-Jurassic extinction wiped out most of the giant land-dwelling crocodile-line archosaurs. But the dinosaurs survived. Why? Because they were built for the long haul. They were faster, potentially warm-blooded, endothermic, and possessed an even more specialized hip structure that allowed for incredible agility. As the Jurassic period dawned, the dinosaurs didn't just step into the spotlight, they seized it. They grew to gargantuan proportions, with long-necked sauropods reaching for the canopy and fierce theropods patrolling the forest floors. The archosaurs had won the Earth. They had refined the reptilian heart into a four-chambered powerhouse and turned the reptilian lung into a high-efficient engine. The world was no longer a place of slow-crawling scavengers. It was a theater of giants. The ruling lizards had arrived, and they would not let go of their throne for another 135 million years. By the Jurassic period, the reptilian blueprint had become the most versatile piece of biological engineering on the planet. Evolution began to pull this blueprint in two extreme directions. First, we look to the horizon. For millions of years, the sky had belonged to insects, but a group of archosaurs known as pterosaurs changed that forever. They were the first vertebrates to achieve powered flight. Unlike birds who fly with feathers, or bats who use 4 fingers to support a membrane, pterosaurs evolved a hyperextended 4th finger. This single massive bone supported a wing made of skin and muscle fibers. From the sparrow-sized Anurognathus to the terrifying Quetzalcoatlus, a creature with the wingspan of a fighter jet and the height of a giraffe, these were not flying dinosaurs. They were a distinct lineage of reptilian masters who developed hollow, air-filled bones and advanced brains dedicated to processing the complex physics of flight. They dominated the clouds for 150 million years, soaring over a world that had never seen such aerial grace. But as some reptiles looked up, others looked back to where it all began, the water. In one of the incredible U-turns in evolutionary history, several groups of land-dwelling reptiles returned to the sea. They didn't just swim, they became more aquatic than the fish themselves. The ichthyosaurs, literally fish lizards, evolved a body shape so streamlined it mirrors the modern dolphin, a classic example of convergent evolution. They gave up the ancestral reptilian trait of laying eggs on land, instead evolving to give birth to live young tail first in the open ocean. Alongside them were the plesiosaurs, the long-necked giants of the deep, and eventually the mosasaurs, the apex predators of the Mesozoic waterways. These marine reptiles were the apex predators of the Mesozoic waterways. They developed specialized salt glands to filter seawater and transformed their limbs into powerful, bone-reinforced paddles. For over 100 million years, the Earth was a reptilian planet in every sense of the word. Whether you looked at the clouds, the surf, or the soil, a reptile was the most dangerous and sophisticated thing in sight. They had solved the problems of gravity and buoyancy, turning the entire globe into their playground. But the ultimate test was coming. An unexpected shadow from space that would demand a different kind of survival. 66 million years ago, a 6-mile-wide asteroid slammed into the Yucatan Peninsula, ending the Mesozoic era in a heartbeat. The world was plunged into a nuclear winter. The food chains collapsed, and the ruling reptiles, the non-avian dinosaurs, the pterosaurs, and the great sea monsters, vanished. The era of the giant was over. But in the mud, the burrows, and the undergrowth, the meek were waiting. The reptiles that survived the KPG extinction were those that didn't need much. They were the cold-blooded masters of efficiency. If you can go months without a meal and slow your heart to a near stop, you can survive a world where the sun has gone dark. From this wreckage emerged the four main orders of modern reptiles. First, the crocodilians. These living fossils are the last true archosaurs on the terrestrial stage. They survived by being the ultimate ambush predators, barely changing their physical design since the Cretaceous. They are the heavy weights of the modern reptilian world, retaining the four-chambered heart and complex social behaviors of their dinosaur cousins. Then there are the tertogenes, the turtles and tortoises. Their strategy was literal armored isolation. By fusing their ribs into a protective shell, they created a defensive fortress that has allowed them to endure for over 200 million years, largely indifferent to the rise and fall of empires around them. The most diverse group today, however, is the squamata, the lizards and snakes. During the Cenozoic, these creatures underwent an evolutionary explosion. Snakes took the reptilian blueprint to a minimalist extreme, losing their limbs to become masters of the subterranean and the stealthy. Today, with over 10,000 species, squamates prove that you don't need to be the size of a building to be an evolutionary success. Finally, we have the rhynchocephalia, represented today by a single survivor, the tuatara of New Zealand. It is a lonely ghost from the Triassic, a reminder of a lineage that once rivaled the dinosaurs. But there is one more twist. While we often speak of the age of reptiles as a lost golden era, look up at the birds at your feeder. Every bird is a feathered, warm-blooded, living theropod dinosaur. They are the lineage of the ruling reptiles that took to the sky and never looked back. From the first egg in the Carboniferous coal swamps to the snake in the brass and the hawk in the sky, the reptilian story is one of ultimate resilience. They didn't just survive the history of the Earth, they authored it.